Good morning, dear all participants. Good morning, sir. So, participants, our today's expert for morning session is Dr. Chandra Mauli, sir, from Central University, Tamil Nadu. Chandra Mauli, sir, before starting the session, I would like to introduce sir. Sir is currently working as Associate Professor in the Department of Computer Science Engineering at Central University, Tamil Nadu. And he has done his PhD from NIT Trichy. And he's having many publications from SCI, ESCI journals to his credit, and his research areas are machine learning, data mining, and IoT applications. Today he would be covering the topic of classification and clustering algorithms for morning session. So thank you, sir, for giving your consent for taking this lecture, and thank you for accepting our invitation also. So on behalf of the organizing committee, I welcome you, sir, for this session, and thank you, sir.
Yeah, thank you, ma'am, for your nice introduction. And am I audible, ma'am?
Yes, sir, you are audible.
Okay. And thank you for giving an opportunity to interact with you people and your participants. And without any much delay, I'll just go to my presentation. I hope that all the participants had a great time in the first 3 days. And I hope that I'll give the same momentum on the 4th day also in the morning session. And to have a good bandwidth, I'll switch off my video and I'll go to my presentation. Can you see my slides?
Yes, sir, it's visible, sir.
Okay. So I hope that the participants are well aware of these concepts, or they are freshly listening to or learning these concepts, or you have a mixed category. So I assume that you are at the initial stage and I proceed from the scratch. So, classification and clustering, if you look at basically, they are the two major problems of two different types of learning techniques. One called supervised learning and another one unsupervised learning. So the learning basically acquiring some sort of a knowledge and that learning part doesn't end with only acquiring the knowledge. You have to disseminate that knowledge also. And interpret it in the way whatever you understood based on the concept or based on the topic, and apply that knowledge to some real world problem and see how it will try to fit into that. So this is what basically learning means. And the learning types, if you see, are 4 categories. One called supervised learning. The second being unsupervised learning. Then the third one, semi-supervised learning. And the fourth one, reinforcement learning. So to do all these things, basically we need to have data. The data can be either text data or image data or video data or general statistical data. So whatever be the type of the data you have, you can try to do some model, generate some model from the data being given. This is the whole process of machine learning. Is you have some data, from the data you analyze it and generate a model, and the model whatever you generate it, you try to evaluate it, and once you do the evaluation, if it is not meeting the high standards, then try to improve the model, and this process will keep in a cyclic fashion, cyclic loop we put it, till the model achieves the maximum accuracy levels. So this is how the whole machine learning algorithms in a skeletal view are being defined. So what categorizes them is what type of data it is and what type of model you are going to fit. Only based on these four categorizations are being done. So in the supervised learning, you will have the data is available for you along with some labels for the data. Labels are sometimes called classes. You have means the data to which what is the core of that particular data, to which category does it belongs to, is what the supervised learning will be. You will apply it when you have this combination where you have data and some labels for every data item. And in the unsupervised learning, you have only data available. There is no labels associated with the data. And in the semi-supervised learning, some portion of the data with labels are available, and some portion of the data with no labels. This is what semi-supervised learning. So the portion of the data where you have the labels, we will try to fit some supervised learning mechanisms. And for the rest of the portion, we'll try to fit into some unsupervised learning mechanisms. And together we try to integrate it at some point through some means. And in the reinforcement learning, you have this is completely a different part where you do some learning on the data with some actions and rewards. So wherever there is some sort of a reward being given for every some action, then such a type of a learning we call reinforcement learning. Particularly these actions and rewards are basically actions, so will be like applying some function on the given data through in some way, and the reward is if the data item passes the function, then you award it by updating the data with the weight adjustment, whatever we do. So reward is basically in terms of a weight adjustment we do. So this is how the total machine learning algorithms based on supervised learning, unsupervised, and semi-supervised and reinforcement learning on these four categorization of learning methods. You can see it. And the problems associated with these type of learning mechanisms, classification is the basic problem in supervised learning. Also, regression is another problem which follows the supervised learning. And in unsupervised learning, the classical problem is either clustering, you apply it on the data, or do some association analysis on the data. This includes both the classification and clustering together will be included in the semi-supervised. And in the reinforcement, you can see some classification problems also people have tried with reinforcement learning. Plus predominantly it is used in control theory applications like controlling an unmanned vehicle, like that. You can find different applications in the reinforcement learning. So with this brief introduction to the classification and clustering, whatever the study we have, it is basically confined to the first two types of learning mechanisms, that is supervised learning and unsupervised learning. So out of this, first I will see regression, then followed by the classification. So regression basically tries to estimate some value of a variable. Either a variable you can say, or some entity, or whatever you can call it. So this estimation is done based on a set of parameters. So this we call it as dependent variable. And these parameters are features or attributes we call. These are together called as independent variables. So why the name is regression is basically this is the antonym of a progression. Progression people might be knowing to progress further, whereas regression is the antonym saying that move backwards. So where is that moving backwards? Basically regression means move backward. And how you are moving backward, why you are moving backward is basically in a typical mathematical scenario, you have some model and the model generates some data. Whereas in regression, the process is in the reverse direction. You have the data, and the data, through the data, you are going to fit a model. So this is what moving backwards means. So let us see with some example. Suppose you have, most of you, or I hope that faculty members, right? It is better if it is much more better if people are a little bit more interactive. I think I'm audible, right? There's no even chat complaining about my. So the data, let us say, since most of you are faculty, I assume that, let us say the data you have some marks of some students available in your class. Say for every student, for different courses, you have different marks, M1, M2, M3. Take a particular student X, he obtains some mark M1 in the course C1 and M2 in the course C2 and M3 in the course C3 in the test 1, or let us say MT1, MT2 and MT3. Okay, sorry, I made a mistake. So M1 only can take M2 and M3. So this is on test T1. In course C1, he got M1, and in course C2, he got M2, and in course C3, he got M3. Then for the same student, in the second test, he got some other marks, say P1, P2, and P3. And you have conducted, since most of us, we have a continuous based evaluation, we conduct it, let us say on the third test, he got some Q1, Q2 and Q3 marks. So based on this, on the fourth test, what is that he may get? If you want to make some analysis looking at his performance in 3 tests. So in this, if you want to make some analysis, how he has performed it in the first 3 tests, based on that, you can try to correlate how much he may get. Accordingly, you can decide the performance of the student, whether he is having any substantial improvement in the courses or not, something like a simple example to estimate. So such an estimate, if you see, so the course 1, marks 1, marks 2 and marks 3 obtained in the first test, second test and third test if you have. Then in the fourth test, let us say the mark is Y4. So this may depend on the previous marks M1, P1 and Q1. And we try to make some relation by assigning some weightage to every test, like this. So this sort of a relationship, this is what called a simple model you are going to try to put, where this is your dependent variable and these are your independent variables and corresponding parameters. So similarly, if you take any sort of this sort of a model, we call it as a analysis or estimation, doing some estimation based on the performance of a particular student in a particular course. For 3 tests, you have the data. Based on that, you are going to estimate the performance of the student X in the 4th test or in the final test. So this sort of a thing we call we can put it regression. And this regression is basically, you can have different types of regression. First one is simple linear regression. So in general, if I put that model as, let us say, I have some y equal to some parameters, whatever the variables I have it, I'll say, let us say x1 plus x2 plus and so on plus xn are the n independent variables, out of which I'll assign weights w1, w2 and so on up to wn, plus some initial mark, I can say initial values W naught and X naught, where X naught basically being 1. So this sort of a relationship, we put it as summation of I, Wi, Xi in a simple short form, we put it for the regression. So this sort of a thing, we call it as a simple regression or multiple different type, and this will fit into this. And in this, if you have one independent variable, let us say you have only x1 and these are not there. And so let us say w0 plus w1x. This form of a equation is what called simple linear regression. And the word linear here basically means if you look at this equation, this is a simple equation of a straight line of the form y equal to mx plus c. So it tries to, over the data, it will try to fit a particular straight line for making an estimate. So this sort of a thing where you have only one independent variable and one dependent variable, we call it as a simple linear regression. If you have the other forms, you have more than one independent variable and one single dependent variable, then you can go for multiple regression. Then if you have more than one independent variable, one dependent variable, then we call it as a multivariate regression. Like this, two different forms of the regressions are there. So whatever be the different form of the variant of the regression, all these regression analysis will try to make an estimate. So I can say simple regression or multiple regression or univariate regression or multivariate regression. All these things basically are different forms of regression where you are going to make some estimation of one or more dependent variables. Whereas one regression of them is called logistic regression. Which doesn't do any sort of an estimation, but it does classification. Classification basically means assign the data to the respective label or to the respective class. So what it does here is whatever be the form of this regression, you have the model y equal to some this form. So we try to make a probability estimate of this, whatever the estimate you have done, probability of the estimate. So P of y, we calculate and assign it to Z. Where basically this estimate, we try to figure it out to one of the possible classes by applying a nonlinear function called sigmoidal function. So this is a sigmoidal function. In this sigmoidal function, this range lies between 0 to 1. So in this function, you apply the variable, you replace it with the estimate whatever you have done, so that you try to, so this classification is like this. you try to estimate the value so that it lies between 0 to 1. So this sort of a thing we assign. So for every data for an unknown test sample, for you make an estimator, then based on the estimate, make a probability of the estimate and then decide whether to which category it belongs to. So the classification, if you define it in a simple language, so you have some data and the data with the labels you have, and what you do is using this data you assign label to the data which has not taken part during learning. Means when you want to, with the given data and along with the labels when you have, so what we do is you are going to study this data and develop some model. So when you are developing the model, what we do is rather than directly take the whole data and the associated labels, we try to split this data into two sets. So this data and labels, we divide it into the part 1 and part 2. So in this part 1, you have some data 1 along with the labels, and in this part you have data 2 along with these labels. So together the union of or you can say data, the whole data is the data 1 plus data 2 makes your whole data. So you divide this into two sets or two partitions such that data 1 is a subset of the original data and data 2 is another subset of the original data. And this data, we try to use it for training. Training means trying to fit a model. So to fit a model based on the given observations, we have to use this data. So in order to not to use the whole data, we take some portion of the data and try to fit a model. And this data 2, we use it for testing. And this testing, we use it to predict or assess the performance of a model. For that we keep it. So in general, either we take this partitioning is either 60 to 40 or 70 to 30 we use, means percent or 70% we use it for training and the rest we use it for testing. So in this way, we see different classifiers. So the mathematically, if you define this data, the classification as so the data whatever you have. So classification can be visualized as a function that transforms the data, which is of d dimensions, into the respective classes k, where k where K equal to some class labels. And this is what the original D-dimensional data. Put it in a vector form. So if you go back to the same example, based on that, estimating the mark of a student, or let us say in another example, if you take classify the given digit into the respective class. Suppose let us say I have two sort of binary images having some images with value 0 and some written 1 in it, and I want to use some sort of a classifier to divide this image into two respective classes, means the image that contains 0 or the image that contains. So in order to do this, you have the data that is represented in the form of D-dimensional data, or it is basically the features, whatever you have it, which are of D dimensions in nature. And using this D-dimension features of the given data, so let us say I have the data, a binary image with 0 written on it, or I may have some image with 1 written on it. So I read this image and do some sort of an image processing operation to extract some features. And let us say this is a feature 1, feature 2, and so on, feature D. So we transform these features rather than representing the whole image. We take some D features of it and put it into transform this image. So the h of x function will transform this feature into either class 1 or one of the values in the given set. So depending on the number of classes, if you have, so depending on the classes, your classification has been divided into binary classification. So classification can be categorized as a binary classification. So all these categories of classification are based on the number of classes you have. So if the number of classes are 2, then we call it as a binary classification. Otherwise, multi-class classification, where it is the number of classes are more than 2. We can call it as a multi-class classification. And you have sometimes a multi-label classification also. Means that we'll see a little later. And the fourth one, you can have some imbalanced classification. Let us not worry about that. And in this, let us say binary classification, you have so many examples. Like this example, I have a set of binary images with having handwritten characters 0 or 1. Or you can classify a mail as a spam mail or not. So in any binary classification, if you take your number of classes are only 2 available. So example, given you want to categorize it into spam or ordinary mail or normal mail. Okay, so the given mail, whatever you get, that mail is basically, if you ignore all the attachments and all, that mail is basically a textual information. So at the primitive level, just taking the text alone, you can categorize it, and this part of this sort of a classification is already executed in any inbox of your email provider, either it is Gmail or Yahoo Mail or anything. By default, certain mails have been already categorized into spam and put it into the spam folder. Means they take in that mail content, if the mail content is having a set of words, So you have a set of words in the mail. So the detector, what it does is it will take this entire text and convert it into a set of all the set. It will try to split every word. Let us say word 1, word 2, and so on. It will take n words, whatever you have it in the entire text, and then it will try to identify it as either spam or normal based on these words, and these words have predefined weightages been assigned. If the mail contains any at least one word which has already in the database of the classifier matches with the set of words that may lead to the spam, so then immediately your classifier will put it into the spam folder. So this is a simple binary classification. Or you can take the digit character like 0 or 1 categorization, or you have an input some handwritten character. You want to check whether it is a vowel or not vowel. Okay, so you have the images having some AE, IOU or some X or some P like this. So read the image and say that this is vowel, this is not vowel, and this is also not vowel. Like that, the classifier will categorize the given image. So anywhere you have either class 1 or class 2 is there, such a classification, we call it as a binary classification. And in the next multi-class classification, you have more than 2 classes available. Take the 2 examples and extend it. Suppose I have to classify the English alphabet. So I have different sort of images having the characters A to Z. So I'll take that image and try to put it into one of the class, and my classes here are basically 26 classes, because English alphabet contains 26 different characters. So this is a 26 class problem. Or similarly, digit recognition 0 to 9. So it is a 10 class problem. So given an image of some handwritten digit, you need to classify it whether the digit is either 0 or 1 or 2 and so on up to 9. So this we call it as a multi-class classification. Whereas other one, multi-label classification. So in general, this binary classification or multi-class classification, we assume that these images are basically binary in nature. Whereas in multi-label classification, you may have some RGB images, colored images, and in the colored images, you may have more than one object. Let us say you may have some sky, you may have some water, you may have some boat on the water, like this, different objects may be there. So within a single image, this image contains, let us say your total aim is looking at whether the sky is present or not, water is present or not, boat is present or not, and assign 1 if they are present. So an image with multiple labels are there, and you take some image where you have some car plus some signal light is there. So you are looking for sky or water or boat, none of them are present. Or you may have some image where you have a man standing over the bank of the water. So in this particular case, you may have water is present, but the sky is not there, boat is not there. So like this is within one image or within one data item, you may have you may have the possibility of the data belonging to more than one class. So this is what called multi-label classification. So like this, and the last one, imbalanced classification. Basically, we work for different sort of outliers classification and all, which are exceptional cases we can think it of. So with this introductory note, if you see, look at the different classifiers, already I have shown the simplest classifier, which is a logistic regression, which is a simple classifier. And another simple classifier is k nearest neighbor. Then you can have decision trees. Then you can have multi-layer perceptron. And support vector machines. And you have some sort of ensemble methods like random forest and AdaBoost classifier. Like this, you can list out so many classifiers, you have it. And in general, most of them can be applied for all the different types of classification. Means you can apply the logistic regression for binary classification as well as for multi-class classification, KNN, decision trees, all these things you can use it for multi-class classification as well as for binary classification. So if you see these things, okay, let us see one after the other. Since logistic regression we have seen, the next classifier is k nearest neighbor, which is also another very simple machine learning model to identify a particular data to which class it belongs to. So one peculiarity of this particular classifier is it has no training involved. So what we do is we just plot the data as a scatter plot. You put means you represent the given data in the terms of an XY plane and then take the input k and try to identify for the query instance, for the query data, identify the k nearest neighbors, and accordingly out of those k nearest neighbors identify the class with the maximum frequency and your query data belongs to the class which have been identified. So such a simple process. Let us see with an example. Let us say you have two-dimensional data. Let us say height and width. You have the data. So you have some data with two attributes and one target attribute. So based on the height and width, you are assigning the person as either male or female. Like this, you have n people having n weights and you have these classes. So what we do is we try to put this data in the plane like this. Say each point here representing some person having some weight hk and some weight wk. And now you have a new person who is entered. Let us say a person entered. This is the new person whose hn plus 1 and n plus 1th person. So what is the corresponding gender he belongs to? So what we do is we take initialize k Let us say I initialize k with some 3. Usually we take the k as an odd number. Means what, by assigning k 3, what we do is we try to find the 3 nearest neighbors. Let us say these are the 3 nearest neighbors of this point, out of which this is for this person is female and this person is female and this person is male, and then since the female frequency is more than the male, we say that the person mostly may likely be a female. Like this we simply assign it. So our assumption may be wrong, okay, so but the k nearest neighbor goes in this way. So in order to have a more accuracy, what we need to do is the value of k should be subsequently a little bit a higher value, moderately higher value you can take. So if you increase the k a little bit higher and higher, then you can try to cover more data points into this region, and accordingly you can make the frequency count and then assign the class. Means if your sample size is very small, then the probability that your estimation or your final evaluation is correct or not depends on the probability is only 0.5. But if you have more data points covered in that circle, then the most likely that the probability that your estimate or your assumption, your guess is correct will be higher towards one value. So this is how the k nearest neighbor will work. And I'm surprised I have no queries so far. Since there were no queries and I was being not interrupted, I am just moving it as much as I can.
Yes, sir, we are getting, sir.
Thank you, sir. So the next one is I'm just giving a overview of all these classifiers. Next one is decision tree. So in this decision tree, you will have, as the name itself indicate, that the resultant model will be eventually some tree, like having some root and with some branches, and these branches may further expand or may not expand. So if they are not expanding, then we end that with a terminal node. We call it as a terminal node, and that means that there is no possible further expansion available. Something like this. So the questions here are how to select. So you have some attributes A1, A2 and so on. N attributes are there and you have a target T. Let us say this target T may have either 2 classes, so it is a binary class, let us assume. So you may have either class C1 or C2, whatever the label 01 or whatever the label you can. So out of these N attributes, we have to select one among them as the root of this decision tree. And to do that, what we do is we try to make some sort of a statistical analysis of this data set you have. So you have N attributes and your data points are D1, D2 and say Dk. K items with the N attributes you have. And each attribute either may be a categorical attribute or a real attribute, means having some real values. So whatever be the type of, what we do is we try to make some the most popular decision tree algorithms, if you see, one is ID3 algorithm, that is called iterative dichotomizer algorithm, or another one CART called classification and regression tree. Whatever the method algorithm you choose, you eventually end up with a similar decision tree. So the ID3 algorithm, it will look at the information gain as one attribute to decide the node, and this information gain is dependent on entropy. So based on these two measures, it will check for the purity of a node. I'm not giving any mathematical formula for all these things, but only giving the mechanism of how they work. Whereas a CART algorithm uses Gini index, which is again based on some probability estimate. This will basically see how impure a node is. And let us not worry about the purity and impurity part. And basically, these are simple statistical formulae which are used to decide a particular which node can be used as a root node. So the higher the information gain, you can see that particular node as a root node, and then expand. So once let us assume that A1 is the root node, that A1 attribute has been selected as a root node, then A1 will be eliminated from the game, and we see the further expansions. So these expansions are based on, let us say this root is now A1, and let us say A1 has three distinct values, say value 1, value 2, and value 3. So with respect to this value for A1, we are going to see the, so let us say I am using the ID3 algorithm. So I use information gain. So with respect to this value, how the information gain values are there with for the rest of the attributes, and then decide one attribute as, let us say A2 I have selected as the branch of this node. And here let us say A3 and A4, like that, three attributes, and rest of the attributes are, I could not make it. Means A2 I selected with respect to value V1, then I filter out A2 also, and with respect to value V2 for the root A1, I select one of the other node, that is A3, and then with respect to the third possible value of root A1, I select A4. And let us say after this I could not expand, means if the root is having a value V2, and let us say the A3 value, you have some value, let us say P3, and all this this combination of the root having V2 and A3 attribute having P3, all belonging to the same class, then we cannot further expand it. If they do not belong to the same class, means A3 has two different values, P1 and P2, and V2 and P1 belong to class 1, and V2 and P2 belong to class 2, means you may further expand. But here we have some value V2 for attribute A1 and some value P3 for attribute A3, attribute A3, and this combination, all the data target values are only one class C1, so you further do not need to expand. Similarly, if you have a A1 having some value V3 and A4 attribute having some value R4, and this combination again belong to the same class C2, then this will be further no expansion takes place. And here A2, let us say this is P2, P4, R4, and let us say this is a Q2. And A2, Q2 value is further not able to expand it. Means A1 equal to V1 and A2 equal to Q2, and the class it belongs to, all these are same class, either it is C1 or C2. So what we do is, this is what called conjunction of disjunctions. Means we take every unique path from the root till the terminal node. So this is what called A1 equal to V2 and A3 equal to V3. This is one rule. Then it belongs to the class C1, or A1 equal to V3 and A4 equal to R4. If this combination is there, it belongs to the class C2, or A1 equal to V1 and A2 equal to Q2, then this belongs to class C1. So like this we can write disjunction of conjunctions, you will make it. And since all the everywhere you have no expansion, so your decision tree is done. Means there is no necessity that all the n attributes will take part in the decision tree formation. Certain attributes means those attributes that do not have any role in the making the decision, means they are eventually eliminated either by ID3 algorithm or by the CART algorithm. So this is what a decision tree, and any decision tree you have, the underlying rule is the disjunction conjunctions you do. So like this, you can further proceed to the next classifier, and I'll stop with that classifier, and then I'll go for string algorithms, and that is a multi-layer perceptron. And let me see the time. Okay, it's already 11:30. Okay, ma'am, shall I break now? As you said, 10:30 to 11:30 is the first session. Shall we continue or we need a break?
Sir, we will take a break, sir.
Okay. So, at when we will further resume? Maybe around 12 o'clock?
Yes, sir.
Okay. Then in the after the break, we'll see the multi-layer perceptron and some clustering algorithms. So if you have any queries in the first part, I'm happy to answer.
Sir, how decision tree will be used for regression, sir? It is widely used.
Yeah, decision tree is widely used for classification. But if you use a cart, then you can
Be
do
used for regression also.
regression also. Any other query? Okay, if there are no queries, then we stop this session and continue at 12.